Probability of simple events. The first thing you want to talk about when you're referencing probability is a sample space. A sample space is a set of all possible outcomes for an activity or an experiment. A sample space is usually denoted using set notation, which is these braces here. Braces surround whatever's inside, and the possible outcomes are listed as elements in the set. So those possible outcomes, in this case, we're using the letters A, B, C, all the way to Z to represent the possible outcomes, and they're surrounded by the braces. So that's our set notation for this sample space. Here are some examples of sample space. So we're going to look at each box below and find the sample space for that event. So the first event is we're spinning a spinner. So you can see here it's spinning, and we have a yellow, a blue, a red, and a green quarter. So that's going to be all the possible outcomes are all the possible colors that the spinner could land on. So we would have in braces yellow, blue, red, and green. Those are the colors it could land on. Then we have the activity or the event of tossing two coins. Well, a coin, this one's a dime, but it could be any coin, has heads or tails. So when you toss a coin, it lands, and you have two options. It could either be heads or tails, but you could have tails or heads or heads, tails or tails. Well, if we list them out with H equaling heads and T equaling tails, you can have the sample space of heads, 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 tails, tails, heads, and tails, tails. Then we have the event of rolling a die or a number cube. Now each side of the number cube is labeled with dots 1 through 6. So that's our sample space. It could either land on 1, 2, 3, 4, 5, or 6. Then we have the sample space for having a jar of marbles. So there's all of the marbles in this jar, and there looks to be about 3 different colors. So we're looking at the probability of picking one of these marbles. So we have to look at picking which color. Well, we've got yellow marbles, green marbles, and red marbles. So that's your sample space. You could have yellow, green, or red. Those are all your possibilities. Now, very similar to the third event, we have the last event of rolling not 1 but 2 die or 2 number cubes. Each one is labeled 1 to 6. So you can have the first one land on 1, the second one land on 1. But then you can have the first one land on 1 and the second one land on 4. So we have all these options between 1 through 6, but for each cube. So that would be all of these different combinations of 1 through 6 for each die. So you have to look at each event and really see what could possibly happen to create that sample space. Theoretical probability. If the outcomes in a sample space are equally likely to occur, the theoretical probability of an event, capital P in parentheses of the event, that's the notation we use, that is a numerical value from 0 to 1 that measures the likelihood of an event. You can write the probability of an event as a ratio, decimal, or percent. So here is a summary. We have the notation we use is, so P of the event is equal to the number of favorable outcomes over the number of possible outcomes. So an event with a probability close to 0 is unlikely to occur. An event with a probability close to 1 is likely to occur. And an event with a probability of 0.5 is just as likely to occur as not. And we can see that summarized in this picture here in this diagram where we go from 0 to 1 with 0.5 directly in the middle and seeing how impossible or how certain that probability is. Here is a non-geometric example of theoretical probability. Starting off small, there are 7 red marbles and 3 green marbles in a bag. 1 marble is chosen at random. Write the probability that a green marble is chosen. And we're using this diagram to kind of set up all the possible ways that we can see this probability as a fraction, a decimal, and a percent. With this type of probability, I think it's easiest to start out with the fraction. We know that the probability of an event is the number of favorable outcomes over the number of possible outcomes. So with the possible outcomes, we have to see, well, if you were to choose a marble, well, how many choices do you have? Well, we have 7 red marbles, and 3 green marbles. So that would be a total of 7 plus 3 would equal a total of 10 marbles. So that's the number of possible outcomes. So now we have to see the number of favorable outcomes. Well, we want the probability. We want the favorable is a green marble. And there are 3 green marbles. So out of those 10, 3 of them would be what we want. So that creates our fraction, our probability, 3 out of 10. As a decimal, 3 divided by 10 is 0.3 or 0.3. And as a percent, that would be 30%. Multiply by 100 or move your decimal 2 to the right. Here's another example looking at our sample space of choosing a card from a deck. This is a standard deck. These are your 4 suits where you have 2 through 10, Jack, Queen, King, and Ace. So we have the probability of picking one card would be 1 out of 52. There's 52 cards in a deck. So let's look at these probabilities. Now we have the probability of picking a heart. Well, we still only have 52 cards, so that would be our total number of possible outcomes. Our favorable would be, well, how many hearts are in the deck of cards? Well, if we count, we see here we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13 hearts. So 13 out of 52 would be our probability, but that can simplify to be 1 over 4. So you have a 1/4 chance probability of picking a heart out of a deck of cards. Now let's look at the probability of picking a 3. Well, same thing, you still have the same 52 cards, but now you only want 3s. There are 1, 2, 3, 4 cards that are 3s, so it would be 4 out of 52, but that simplifies to 1 out of 13. So you have a 1 out of 13 probability of choosing a 3 from a deck of cards. Now let's look at the probability of picking the 4 of spades. There is only one 4 of spades in a deck of cards, so that would be 1 out of those 52 cards, which simplifies still to 1 over 52. So that is that probability. Here is an example of probability using the event of rolling a number cube or a die. So here we can see we can keep rolling this number cube. We have a side of 6, a side of 5. Here it landed on 6 again. Now we have 3, so we can land on we have an equal chance of landing on any of these sides, which are numbered 1 through 6. So our sample space for this activity are those numbers. We have 1, 2, 3, 4, 5, and 6. So now if we want the probability of each of these events, we know this is our sample space. This is the total number of possible outcomes, which we have 6. So that will be our denominator for each of our probabilities. So first we want the probability of a 2. Well, there's only one outcome of having a 2, which is when it lands on 2. So that would be 1 out of the 6. So that probability would be 1/6. Then we want the probability of having an even number. Well, now we have to look at our sample space and look at the even numbers. We have 2, 4, and 6. So that's 3 options out of the total outcomes. So 3 out of 6, which can simplify to 1/2. So you have a 1/2 probability of picking an even number. Now let's look at the probability of a prime number. Prime numbers are only divisible by 1 and the number itself. So that is only going to be 1, 3, and 5. Again, 3 out of the total outcomes in our sample space. So that would simplify to 1/2 again. So it looks like the probability of choosing an even number or having the die land on an even number and a prime number are the same. Finally, let's look at the probability of getting a number greater than 4. So now we look at our sample space and we see 5 and 6 are the only options. So 2 out of 6 would give us 1/3. Here is an example with probability where the event is spinning a spinner. So here, every time I click on the spinner, it's going to land on a different color. That time it landed on orange, now blue, now green, now orange. So every time we spin the spinner, it's going to land on one of these colors. So those colors are going to be our sample space for this event. It can land on the color blue, green, red, or orange. So now, with that sample space, let's look at the probability of these events, first of landing on green. So green, there's only one outcome where it lands on green out of the 4, so that would be 1/4. With orange, it's the same. There's only one outcome of the 4 where it lands on orange, so it would be 1/4. So you actually have the same probability of landing on green, orange, or blue or red for that matter. There's only one outcome with those 4 colors each. So you have a 1/4 chance. Finally, let's look at the event of tossing a coin. So here, when you have a coin, you only have, you have a quarter, a dime, a penny. Here we have a quarter. So here we're simulating tossing a coin. So we're tossing and then we stop. So now it landed on tails. It's starting and now it landed on heads. Starting and now it landed on tails. Tails. Heads. You could keep flipping it or tossing it, but there's only ever 2 possible outcomes. You have the sample space of just having a heads. So we'll say capital H for heads, or tails, capital T for tails. So now that's 2 possible outcomes. Now the probability of heads would be one of those outcomes, so 1 of the 2, or 1/2. Same thing, the probability of tails is only one of those outcomes in your sample space, so that's 1 out of 2 as well. So the probability of getting heads or tails are equal. It's 1/2. So you have the same chance or the same probability of it landing on both. So no matter what the event, you have to look at the sample space and then look at the probability. What is your favorable within that sample space out of the total?